All right, here we're going to go over the graph of the arctangent function. So to begin with, what we're going to do is sketch the tangent graph, and then we'll, from there, sketch the graph of the tangent inverse. So actually, what I'm going to do is a modified tangent graph where we restrict the domain, and I'll explain why we'd want to do that. So, okay, so first of all, I'm going to put some asymptotes here for the tangent graph. I feel like the dotted line just doesn't look as neat. So what if I tried to just do a really much lighter color for that asymptote? Is that going to do it? It's maybe not. So, okay, I'll just do the dotted line because that's the convention. Okay, so I'm just spending a bunch of time doing that. And all right, so what I'm assuming right now is that we know this graph. Okay, then I'm going to pick a nice color here and go ahead and draw this. Okay, so that's the tangent graph where we're just looking between negative pi over 2 and pi over 2. Now, what I could do is I could extend this just to remind us that the graph continues. So the purple part is my answer, but I just want to show you, because I want to point something out, that tangent's periodic and it goes on forever. So the purple part is the part that we want, and make it even darker or more bold. Okay, so this purple part is our answer. So here's the observations that I'm going to make. The graph, the function y equals tan x fails the horizontal line test. And what can we say about that? And therefore, it is not one-to-one. All right, so if you look at the tangent graph, which I've sort of lightly done here with yellow and it's showing yellow, then that graph's not one-to-one. The function y equals tan x, but this time with x bounded or with restricted domain between negative pi over 2, passes the horizontal line test. So the horizontal line test means that if I draw any horizontal line, it intersects at most one time. So anyway, so you can just draw a horizontal line here. So we can see that it only intersects at one time. So this is just, any horizontal line. We can see that any horizontal line intersects only one time. So therefore, why would I even bring that up? Therefore, y equals tan x. I'm going to write this times x in negative pi over 2 to pi over 2. That's another way to write it. Is invertible. It has an inverse. All right, so this lecture, this little video is on the graph of arctangent function. This is all a bunch of build up to that, and maybe it's a little bit too slow of a build up for some people. So anyway, but that's what I'm pointing out, something that's true, and I think it's going to give us more insight on the graph of tangent inverse. Okay, so how do we sketch the graph of tangent inverse, aka arctangent? What we do is we note that we find the inverse of y equals tan x by swapping x and y. So we find the inverse of y equals tan x by swapping x and y. Okay, so what we get is x equals tan y. That is the inverse function. However, when we write functions, we like to have our y sitting on the left-hand side of an equal sign. So this means or is equivalent to y equals tangent inverse. You know, the one thing to really keep in mind is that this -1 does not mean reciprocal. So that is, or maybe even better, is to write aka, otherwise also known as y equals arctan x. Okay, so a lot of talking there. By the way, let's just maybe go over here back to this graph and make sure that it's clear that these are vertical asymptotes. And also, let's just make clear what the range of this graph is. The range of the graph is all real numbers. And what we're doing is we're restricting, as it shows, x between negative pi over 2 and pi over 2. So this is our domain of our restricted graph. Now, if I'm using the variables x and y, domain corresponds to x and range corresponds to y. When we swap x and y, what that does is it interchanges the domain and range. Okay, that's one thing, and I'm going to write that down, follow up on that more. It's also going to swap the vertical and horizontal asymptotes. I mean, when you swap x and y, what's a vertical asymptote up here for our tangent graph becomes a horizontal asymptote for our arctangent graph. And so I'm going to draw those horizontal asymptotes. I'm sort of thinking about spacing and what looks the best. If I use the same spacing as I have over there, I just don't think it's going to look as good. So anyway, I'm going to not use exactly the same spacing. Okay, so the vertical asymptotes are x equals negative pi over 2 and x equals positive pi over 2. Those become horizontal asymptotes when we swap x and y. Now, finding the graph of the inverse can be thought of as being achieved by doing a reflection around the line y equals x. I find that just a little bit of a challenge for me personally. By the way, at pi over 4, we know that the tangent pi over 4 is 1. At negative pi over 4, we know that the tangent negative pi over 4 is negative 1. So that gives us 2 points. Well, we have the origin as another point. Sorry, that's sort of hard to read, but I don't know. I don't see how I can really do all that much better on that. I can try, but no, I sort of ruined that. I don't think I picked the same color either. Okay. Yeah, I don't know. I don't know whether I can do that to get it really good. Not so good. Okay, anyway, so all right, so so I'm sort of arbitrarily picking one. Well, this is, okay, if I want to keep it to scale, this is going to be a little bit tricky. So, okay, anyway, I'm just going to draw the graph. Once I start getting too excited about drawing the x and y to scale, then the whole thing starts getting a little bit difficult. So this is what it looks like. And if you wanted to say that this point over here is, say, pi over 4, then this one here would be, say, 1 pi over 4. And then down over here, am I keeping the scale the same? -1, negative pi over 4. Here the x and y are not to scale. Yeah, it would have been better if I made this scale, but it's okay, I think. Okay, so that is the graph of y equals tan inverse x. And before I leave or stop, let's look at what the domain is. The domain is all real numbers. The range is the interval between negative pi over 2 and pi over 2. And I should also point out that it's increasing, which is, sort of interesting. And it's also 1 to 1. So also, if you think about it, we studied before rational functions, and they had these, they had horizontal asymptotes, but none of them have two different horizontal asymptotes. I'm also going to point out something. This is going to be more of a calculus notation and topic. As x goes to infinity, y approaches what? Pi over 2. That's the same thing as saying there's a horizontal asymptote at pi over 2. As x approaches negative infinity, y approaches negative pi over 2. Okay, so those are like little bullets or something or other, bullet points of this. But here's our graph of y equals arctangent x. And I think that covers everything there for that. So, all right, there we'll stop then.